Hello everyone, my name is John Akladus and I created this project along with my partners Efaz Rahman, Vishnu Yadagani, and Joani Kaleshi. This project is called IceScopeGL and is our entry into the 2025 MiSpace Hackathon. Now let's get started with the ice forecast layer of our project. Now as you can see here, we've used the 21 days of data, made a machine learning algorithm, and made it into concentration, thickness, and type data for parsing easily. So the first thing here we have is concentration. And as you can see, the legend goes from 0% to 100% concentration of ice. And our thickness data also goes from 0 to 3, visualizing the thickness of the ice along the lake. As well as our type, which breaks down basically the type of ice along the lake. Now the most important part of this thing is really our 4-day future period, which shows what the ice is going to look like 4 days into the future. And as you can see here, we can tabulate through the ice and take a look at the forecast and make sure that, for example, if you were in the Coast Guard, you would avoid those parts, or for trade routes, for example, those parts would be avoided if there's heavy areas of ice within those areas, or maybe the route would be planned around it, which is what we're going to get into next with our best route function. Now, the introduction of our best route function, you can see that we can draw routes using these two things. So for example, if I want to draw a route from here to here, I can, and if I want to draw a route anywhere along lakes, I can do that. And you can see here, it tries its best to avoid land. So for example, it's avoiding these two islands right now, as well as the whole coast of Michigan. And this is just important because it allows us to make sure that we can avoid ice and land and make sure that we're drawing out the best trade routes for the Coast Guard again, or for different suppliers along the lake. And the most important thing here is also that we can use our start and destination tabs, meaning that we can also pick presets into which cities we want to go to. So for example, if we wanted to go from Chicago to Milwaukee, we could make that route, as well as going to other cities along the Great Lakes. And it's just very important because we also have overlaid our ice data here, so you can even see in real time, while you're building your route, where it's going to be heavy and where the ice is going to be heavy in order to make sure that you're avoiding those areas. The next thing that we have here is our real-time temperature function, which shows us real-time temperature in any city that we search up. And the last thing that we have here is our alerts, which shows us all the alerts that are currently happening across the Great Lakes. So for example, if we take a look here, we can see that there are a lot of alerts happening, and if we just choose one, we can take a look and see that, for example, we can see the severity of the alert, we can see when it expires, and we can also see the area in which is being affected by the alert, in the case that we need to make sure that we're drawing proper trade routes for the Coast Guard, or again, for any suppliers that are trading. And with that, thank you judges for listening, and we hope you liked our project.